All righty. Hi, everyone. I am super excited to introduce the next speaker that we have for y'all. We have Joe from Solana, who's going to be teaching y'all how to get started hacking with Solana. So without further ado, I am going to bring them on here. Hello.
Hey guys, what's going on? I'm Joe. I work at Solana Foundation's developer relations team. So my job is basically to help you guys learn how to dev on Solana and basically like upskill your Solana dev skills. So today, what I'm basically going to do is I got a couple different like running D apps built on Solana, and we're going to just like take a look at them and kind of like see how they're built. And are you able to see my screen then? Just want to make sure.
I think your screen share right now is just the StreamYard link, it looks like.
What do you mean?
Like it's just the like the view of StreamYard. Okay, there we go.
Yeah. Okay. Yeah. No
Okay.
worries.
I will leave you to it.
Cool. Yeah. So basically, to start, I want to take a look at. I have some running apps here that I want to allow you guys to interact with. So if you could just share these links with the crew, that'd be good. So the first one is a real simple one, and it's called this like SVG generator, right? Actually, I don't think this one's online. So I think what we're going to do is we're going to look at the Twitter one. But either way, so this one is basically a Solana built version of Twitter. And you can see that like I'm the lonely tweeter on here. But go ahead and head over to this link here. And I'm going to put it in the chat. And then if you could just share that, please, Mary. You guys should be able to go to this site and connect a wallet. You can use Soulflare, Phantom, or Glow. You just have to have the Chrome plugin or whatever browser you're using. If you don't have that set up, you're welcome to and get it set up and run some tweets. You also don't have to; it's totally up to you. But for those of you guys who don't have that set up, you just search download Phantom Wallet, and then when you open it up, you could see that there's a couple different browsers that it supports. You just hit Chrome, and it'll have you generate a wallet or import one. So feel free to mess around with that. But I'm going to just show you guys how this thing works. So for starters, when you first come in, this is what you'll see, right? You'll have no wallet connected, and it'll tell you that you need to connect to sign up. And once you do, you'll hit this button and you'll see the supported wallets. And this is one of the components that we'll look at, like how this thing's built. I'm going to choose Phantom. And then I've already created an account, so it loads my account. But if I didn't, like if I was to go ahead and use a different wallet, and I'm on DevNet, by the way. So like if you guys are interacting with this, make sure you go ahead and click this developer settings and change to DevNet. But let's go ahead and see what happens if I change to a different wallet and I go to connect with my Phantom. It's going to actually have you, it's going to ask for your approval to connect to this app. And then once you do, it's going to want you to set up a profile. And this is just going to be my second one. And so when you create that, it's going to give you this transaction preview, and it's going to show you that it's going to cost you a tiny bit of SOL to actually create a new account. And that's because to create a profile on this Twitter app, we're actually creating an account on Solana that's going to store our like username and stuff like that. So you approve it. It should take you back here, and then you should be greeted with the tweets and then the prompt to write your own. And you can just type something. And just like before, if you go to publish a tweet, it's also writing that to the chain. So you're going to have to pay a little bit of SOL for that. And then the cool thing is, if I go ahead and so like I'm on a different account right now. I'm on JoeC2. If I go and like one of my tweets from JoeC1, look at this one getting all the likes. If I go and hit that, it's also going to prompt me one more time. And that's because what this app is designed to do is when I like somebody's tweet, it's going to mint them a token to whoever authored the tweet, right? So like this is like a decentralized form of Twitter. Like every time I get a tweet, like I get minted a new token, and the person who likes my tweet will pay for that mint. You can see it's very, very inexpensive. This is like less than a cent. But the idea is if I got like 20,000 likes or something, like it'd be pretty cool. And so I go ahead and like that. And then if I just switch back to my other wallet real quick, I can show you guys that I literally have in my wallet these like tokens, right? And retweet tokens. And I've run this test a few times, so I have some duplicates, but you can see that I have these in my wallet and I can see them and I can open them up and you can see that I just got this one now when someone liked my tweet. And you can actually view the transaction on SoulScan and you can, or Explorer, whatever your wallet's set to. And you can see like the information about that mint. So pretty cool. And this app might seem a little complex, but it's actually not that bad to set up. So we're going to take a look at how I built this, and I'm going to show you some of the like key components that you'll actually want to use to build your D app. So for starters, what we can do is this application, I'm going to give you guys the link here as well to the workshop repo. But basically, these are all the repos for the workshops that I've run. Just going to close some of my windows here because I'm going to confuse myself very quickly. These are all the different workshops and all the code. We're going to be looking at the Solana Twitter one and mainly the V2 version. And so what you can do for starters is this app is built in Next.js. You don't have to use Next.js, but the idea is this came with a bunch of like prefabbed components and like cool stuff out of the box, including this context provider. And basically what this thing is this is a context for React that is going to use the Solana wallet adapter library. And it's going to basically allow me to create a hook that's going to detect whether or not my wallet has been connected. So if you look at like the component for Solana Twitter, you can see right here, we're using use wallet. And that comes from the wallet adapter React library. But we also can use this context to automatically connect a wallet, which is why you'll see in the app, if I just do a refresh and I've already approved this app before, most of the time this will auto connect. But yeah, so like if I try to just like go to it again, you can see it connects right away. I don't have to like reconnect it after refreshing. So that's what this context will do for you. The hook will come from the library, and you can see that you get the public key of whatever connected wallet, and then the function to send a transaction, which you can see it's highlighted down here. This is what we're doing to create a new Twitter account, right? Like we're just creating the transaction, and this is just like a separate file I have with all the functions to create these. And then we're just sending it. And when we do send transaction from this wallet function, that's when it prompts us for the signature and it gives us the preview and all that stuff. So literally this send transaction function will package all that up for you. Pretty cool. And then another neat feature as well is as part of this scaffold, we got some of these components. So like we got this app bar, which is just like this top piece here, and you can customize it, but it came out looking like this. And then like we get this footer and some stuff like that. And in the app bar, you can see is the wallet multi button. So like even if you do or don't use the app bar as it's gen for you, you can just add this multi button. And so the cool thing is you get this wallet stuff, you get some other cool like configs, and you also get like this is the app folder. You also get a programs folder and all of your different configs if you use this CLI that we have, which is called the Create Solana DApp CLI. That looks like this. You just do npx create Solana DApp. I wish I could move that up more, but npx create Solana DApp. I'll just clear. And then I'm just going to call it example DApp. And if you do like create Solana DApp help, all you have to do is have npm installed for this. You can see that here's the menu, and it tells you that you need to provide a name for your project. And then you can also add these flags if you want to specify if it should be Anchor or native, and if you want to use Next, Vue, and then there will be more supported in the future. But so this will dictate what kind of like framework you want for your program. So it'll set up your Rust repo and like set some configs. And then this one will obviously do your front end framework. And that's what's going to give you whatever kind of scaffold that you want to use. So like in this case, this is the next scaffold. And it came as a next boilerplate app that had all of these Solana components in it. The Vue one is just the same. It's just written in Vue, and same with like React. So the idea though is like it's coming down as a scaffold with all of these like Solana things in it. So pretty cool stuff. And then you can see like if you just give it a name and you let it use the defaults, it'll tell you what it's going to use, and it'll just go ahead and spawn that for you. And then you can see there's all your stuff. And there's probably way more stuff in here than you need, but it's a great way to just like kick off and get started. And then another tool I'll show you guys here is beta.solpg.io. This is an online IDE for building Solana programs. So one cool thing you can do, and I'll share this to the chat as well, is you can actually go to the workshop repo, and sorry, I'm still very clunky on Mac. I'm more of a Linux Windows guy. But you can go to the repo, you can go to the program that we're working with. So let's go to the V2 program. And once you hit this directory that has source, like the cargo root, you can copy the path, you can go to SolPG, and you can import it. And once you do that, you can see here's our code. So you guys are welcome to do that. You can go ahead and open SolPG yourself. When you do it for the first time, you'll have to connect a wallet, and you can either import one or you can just generate a new one. And then you can just go up here, click this, and airdrop. So pretty neat stuff. And the idea is when you have a program in here, you can hit this wrench and hammer thing and you can build it on the IDE. And watch how fast this is. So this is a pretty good sized program, and it's built using Anchor, which automatically makes it much larger because there's extra code that you're not seeing. That completed in 4.5 seconds. If I wanted to do that locally, that would take a lot longer than that because this is a cloud container backed builder. So it's pretty cool. It helps you like develop a lot faster. And then once you build it, you can actually export your IDL, and it will just download it as a JSON, and that'll actually live. Like you can just tuck that into your front end. So like I've done it right here. Like I just went and tucked it into my utils file or my utils folder. And once you do that, you can use it to build your front end. And I'll talk more about this in a minute. But basically SolPG is really useful. You can also deploy your program from here. It'll give it its own ID and stuff like that. So this is a great way if you guys don't have like Solana and stuff installed, or if like your local environment's less than stellar for Rust development, you can just use this thing and you can import my program and we can take a look at all the code. So the IDL is basically a representation of everything that is in your program. And you can see that like the top level fields are instructions, accounts, and metadata, alongside some other stuff. And so the accounts are going to be all the different kinds of accounts that your program supports and their data types. And this is going to be used for serializing the data, right? So like, how do I create this account and what kind of like fields and what data types do they have? And then the instructions part is going to be like, what am I sending to my program to do something? Like this instruction is going to be to create a mint for the likes. So these are all the accounts you need to include. And then these are the arguments, which in these cases, there isn't any. But down here, if you look at one of these args, you can see that like this instruction requires 2 strings to be passed into the program. And so what's cool is if you look at like a native version of a program, you can see that you originally would have to set this thing up, right? So you take in your instruction parameters, as you're probably familiar with, and you basically read in the instruction data from a byte array and you turn it into an object. So this can be a little bit like inundating to do, especially if you're new to Solana development, because like not everybody has developed where they've worked with bytes and like buffers and like serializing and deserializing. So it can be a little tricky. And you could even see that like when you go to create an account, you're also having to do serialization. But if you look at Anchor, which we're using for this Twitter app, that's all being done for you. So if we just look at like the create mint, like if we just look at this, It's a little bit confusing because Anchor has a lot of like embedded methods, but this is going to create an account for you right here just by using this keyword. And so all you need to do is pass the public key in, and you don't need to worry about like, is it a signer, blah, 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 because when you set up your program, you're going to make all of those requirements, right? Like we've required a signer down here, etc. So, couple things here. This might look like a lot of code, but it's only because some of these methods take a ton of parameters. So I'm going to start with an easier one. And mind you, we're using Anchor, but like the overall structure of this on-chain program, you can do it in Anchor or native. Just the specifically Anchor stuff are going to be like where the functions that I'm using to do some operations, and I'll call those out. But I'm not really going to focus too much on their native counterparts just because like we don't have a ton of time for that, I don't think. But anyway, so if we walk through the app as we looked at it, the first thing we did was create a profile. You saw me do the Joe C2 one. So that looks like this. So first of all, our entry point here supports all those different instructions that we saw in the IDL, and they're just directing us to like different files. And so if we're going to create a profile, then we're going to enter this function here. And with Anchor, what you can do is you can actually tell it to initialize an account before you even enter your operation. And that's what like all of this junk really is. Like if you can figure out how to like look past these annotations, this is really just a struct with a bunch of accounts in it. And you can see that these accounts have certain data types. Like this one's a token account. This one is a mint. And then like this one down here is our profile, right? And so when I'm creating a profile, what this program is going to do is it's going to create my profile. It's going to create a token account for my profile to accept retweet tokens. And it's going to also create a token account for my profile to accept like tokens. So whenever I do enter my information, that's what's going to happen, right? So now when I finish that and it writes this stuff on chain, I've got a profile that's under my wallet. And I've also got the token accounts required to receive these airdrops of like the tokens whenever you like or retweet my stuff. So that's why we're setting all that up. And then we're passing in like the mints that we're going to use for these token accounts, because you need those to actually create the token account itself. You need to know what the mint is. And so like you can see here, associated token mint. And then we're just telling it like for the retweet token account, it's going to be the retweet mint. Now, I know this looks like a lot of code. It's mostly a lot of like multi-line stuff. And with Rust, you do like all these long paths. You don't have to, but just depends on how you lay it out. But it's not as bad as it looks, right? This is actually a little bit more of like a complex instruction because, yeah, we're only just going to create this profile, but alongside it, we're doing a couple other things to set up the usability of our app. So hopefully that makes sense. If you guys have any questions throughout, you can throw them in the chat and Mary will forward them to me. And I'm happy to elaborate on anything. But again, just don't be intimidated by how many lines of code there is. This is really just creating a couple things and using a bunch of other accounts as reference. And just to show you on the client side what that looks like, we saw the IDL, right? And here's all the accounts that we need to create a profile. If we look at our function to create a profile, you can see that right here, we're just including a ton of accounts because we need to, right? Like we need to include this program to create an account, this program to create a mint or to create a token account, this program to create a token account, right? And then we need rent and we want to sign it, right? So we want to make sure that your wallet is the one that's going to be like the master of all this stuff. And then the rest of these are associated with our app and the profile that we want to create. So a lot of accounts, but this is one way that you can get all of that functionality that we have. And so with Anchor, we set up our program, and that's just coming from this like get configs function, which is just setting up what's called an Anchor provider. And all this really means is it's just loading your like local Anchor configs, and it's pulling in your IDL. And then it's just returning a couple different objects. So you have the provider, which is like your connection to the network. You have your program, which is like the program itself represented in an object in JavaScript. And then this seed util is just a function that I use to derive like PDA addresses, which I'll cover shortly. But anyway, so going back down to creating a profile, you can see that we just go and hit instruction, and then we pass the instruction in a new transaction to the front end. This is not how you have to do it. This is just one way to do it. I personally felt like this was a little bit easier because what you do is you return a transaction, and then your front end component right here where it's like on click create account, all it has to do is just get that transaction and then use the wallet send transaction function, and it'll add the signer from your wallet. So that's why we saw that earlier. So kind of cool, right? We're just using the wallet adapter from Solana wallet adapter, and we're just using it to send that pre-built transaction. And so that process is how it works to basically create each of these on-chain accounts. So like when we look at our program, creating a profile, like if you look at just the operation itself, we're just going to set up a new object of this data type, Solana Twitter profile, and we're just going to run set inner on the profile account. And that just means that we're going to set the inner data to this profile and all the stuff that's in it. So that is the same process for creating a tweet. Same thing, right? Creating a like. You actually just add like some fields, like this is what the like looks like. You just have some public key fields, right? So like when we're liking a tweet, we're creating this account on chain as a record of like, okay, this wallet and this wallet's profile are submitting a like on this tweet, and the authority is the wallet. I think this one is the tweet author's wallet, but either way, it's like, okay, this is going to link all of those accounts together, and it's going to record that we have liked this person's tweet. And so on and so forth. This is how each of these instructions work. We're just creating new accounts that represent data, and like a profile just has some like associated data with what the profile looks like. A tweet has like who wrote it, and then it has a body, and then like there's some count values here, like how many times has it been liked, how many times been retweeted, what tweet is this, like from the profile, and stuff like that. So basically, before we get into the weeds of how this thing works, because an important component of this app is the data mapping, I want to just take a look at the running application one more time. And I just want to say, like, okay, each of these components is obviously hooked up to what I showed you with the transactions. I'm going to give you guys a minute to ask any questions about like some of these instructions on chain, and then I'm going to talk about how these accounts are related and how this is built leveraging PDAs. So like taking a look at create profile, just scrolling through this again, right? Like anytime you see this mute keyword, we're just doing some validation against it. Like we're making sure that it's got this number of decimals, we're making sure that this is the mint authority, we're making sure that the public key was derived from these seeds, and we're marking it as mutable. So this whole block, anytime you see this block, that's all we're doing. So we're going to read these accounts in and create a token account, right? So all this stuff is, is pretty much standard across this. This one has much less, right? Because to create a tweet, you don't need to worry about the token accounts. You just write the tweet, initialize it, and we just need to reference the profile, and we're just making sure that it's owned by the wallet that is writing the tweet. Any questions, pop them in there. But this is where things Solana-wise can get a little bit confusing. So what we want to do for a moment is think about how this application would be built in Web 2. So I swear I'm going to go to the left every time I try to go here. So if you wanted to build this app in Web 2, one like really common way you would do it is you would basically store everybody's profile information in one table. Let's say we're going to use SQL. we would store everybody's profile information in one table, and then they would have a profile ID. And then we would store every tweet in another table, and it would have a tweet ID, but it would also have a profile ID so that the SQL server can relate tweets by that profile ID, which is called a foreign key, to the profile ID of the profiles table. So if I'm profile one and I write a tweet with profile ID one, the server, and when you go to read, will know that this tweet came from profile one, which is me, like has this information, and so on and so forth. Like when you do likes or retweets, you would just create a table for a like, and it would just be like profile ID of the liker, tweet ID of the tweet. And that's really all you need to include because it's just a thing. It's just a like. There's no like associated metadata or additional fields. So that's like how you do it with SQL, right? So, it makes sense to have the private, or I mean, the like primary and foreign key relational mapping because that's a pretty like common way to do things in Web 2. So when it comes to Solana, and this is kind of specific to Solana because it's the way the architecture is designed, you have to basically create those relations almost manually, right? So like you have to have private, or I keep saying private, you have to have primary and foreign key mappings basically created on your own. And I'm just going to check the chat. Okay. So you have to do that kind of on your own. And if you guys have ever heard of a PDA, or a program derived address, that's exactly what these were designed to do. So for starters, each of these on-chain accounts that stores data, so like my profile, and then each tweet, each like, etc., these are all on-chain accounts that are owned by my Twitter program, like the Twitter on-chain program that I've created. And the reason that that's the case is because when you create an account on Solana, only the owner of that account, which is always going to be some program, can modify its data. So like in the case of a wallet, my wallet is actually, like, you could see what a wallet really does is it houses a number of different Solana accounts in it. So like this is one Solana account, this is another, and then you can view your tokens inside of that wallet because these are all the token accounts that you have derived from your wallet itself. But your account, your main account that has your SOL balance, that's owned by what's called the system program. And that program is the default native program. It's in charge of transferring SOL and creating new accounts and just managing ownership. That's the default. So your account that holds your SOL balance on Solana is called a system account. And it just means it's owned by the system program. When you create a token, your token account is what holds your balance of that token. But the token mint itself, like how you know that it's USD coin or how you know that it's like Solana Twitter like coin, that's a mint account that's owned by the token program. And that's because only the token program can manage its data. So in our case, when we write tweets, our program is the one that can create new tweets. And let's say you wanted to like update your profile, our program is the one that can actually update the data inside your profile. And what you can do is you can say, yeah, my program owns this account, so it is the only entity that can write to this account. But let's say based on whoever the wallet that created this profile is, I don't want anybody to be able to change my profile. And that actually looks like this. So if we look at creating a profile, you can see that here's the instruction to create one, and here's the object of a profile. So we store this authority field in here, and this is our wallet. So we're calling it authority because that's what it is, right? It's like our program is allowed to change profiles at any time. So we need to add a check to make sure that the person who sent the instruction to modify a profile is actually the one who owns that profile. And you verify that with a signature. So you'll see like here is the authority that we're storing in the Twitter profile itself. And when we go to create the profile, you can see that, or actually let's just do like a tweet, right? Because I don't have an update profile function, but you can see that here, when we do this has one equals authority, we're making sure that the profile, that authority field inside the profile matches the signer of the transaction. So in this case, it's like I'm trying to write a tweet with my profile, and this check right here on the on-chain program is going to make sure that I am the one who owns this Twitter profile. So that's what you want to do. Your program is basically given read-write access to the database, which is the Solana blockchain, and you have to add the necessary checks in your on-chain program to make sure that like the right people are accessing the right data. So it's a little bit tricky to think about, but you can almost think about your on-chain program as like a service in a lot of ways, like an on-chain like data service, data management service, even like a SQL server maybe. And you can add all these different like configs and gates and stuff like that to manage the data. So that might be a little bit confusing, but basically you just have to remember that programs own accounts and they are allowed to do stuff to the data. And then you have to set up all the different like restrictions. So with that being said, these are all owned by the program for that reason. Makes sense. We want our program to be able to do these operations. We can just add some signers. Like that's totally cool. But what about like, how do I find this data, right? Like that's the second issue that you face. The first issue is who owns it and who can change it. The second issue is like, how do I know like what tweets belong to me and what tweets belong to someone else? So you can see that my front end, it knows that this is my tweet and it knows that this is my second account's tweet. And if I had like some edit functions, it would know that I can't edit someone else's tweet. And so you might think at first, like, oh, that makes sense because like we have the references in the data type, right? So like when you write a tweet, you know what profile it came from and you know what wallet it came from. So it's like easy when you load the tweet to know which profile it belongs to. And then you can just use this public key to go look up the profile information. But how do I know what the address of the tweet is? Like if I'm sitting here and I'm creating this front end and saying, yeah, show all the tweets. How do I know what these tweet public keys are? How do I know what these addresses are? And like, how do I just load all these? Like basically what's the equivalent of a SQL statement of select all from table tweets? How do I do that with blockchain accounts that have addresses? Well, basically what you can do is you can create what's called a program derived address. And that's what this seed does. And if we look at our, like, let's go to create profile, for example. When you look at all of these like anchor macros, they have a bunch of like fields in them that are doing different things. But one of the most important is going to be this one that says seeds. And you can see that these seeds are what we want to use to, and you can ignore bump for now. That has to do with seeds, but it's a little bit outside the scope of this tutorial. But I can cover it towards the end. But basically, these seeds are what are going to be used as input parameters to a hash function that will give us an address. So if I feed that hash function this constant and your wallet's public key, I will get your profile address back. And since our app starts with your wallet being connected, we have your public key to start, right? So that's our entry point to the blockchain is we know your wallet's address. So we can use your wallet's address and we can hash it with this constant, which is literally just the word profile in this case. And as long as you put those two parameters in that order, that hash function will return the address to your profile. And the cool thing is, it doesn't matter where you run it, as long as it's the same function. So like on chain, it will return your profile's address. And that's why we're using it to create it here. And also off chain on the front end as well. So like in the React code, in the JavaScript end, you can also use it. And that's how we know that your profile is the one that we display up here in this like create tweet box. And that's why there's also only one. So this is what's called a one-to-one mapping. For any one wallet, we have one Twitter profile. So your parameters are simple: the constant profile and your public key of your wallet. And it helps to kind of think of this seed prefix as like your table name. So that helped me out a little bit. But so that makes sense, right? So now we know from your wallet address that we can get your profile address at any time. We don't need any additional information. We can always know what your Twitter profile is by your public key. And that's why when I disconnect and I use a different wallet, that's how the app actually knows that you don't have a Twitter account yet. So first, the wallet's going to tell you, because it's not recognized by the wallet, like this is the app of the wallet. And then you can see that we have to create our account because our app has done the derivation. It has hashed together this public key and the word profile, and it returned no existing account. So the app says, okay, we just looked it up. This account doesn't exist. You need to create it. And once you do, that's when it will actually create that account. And then we'd be able to do that derivation over and over again. So that's the way that finding a one-to-one relationship works with a PDA. The trickier thing to implement is one-to-many relationships. Cool. Get some tweets in there. I'll sauce you like. But anyway, so one-to-many relationships are a lot harder to implement. So this is where things get a little bit like hairy with the technical end of things. So following the same concept, right? Like we're going to use, let's call this the table name, the seed prefix, to hash together. Let's take a look at what the hash looks like for creating a tweet. So if we do create tweet and we have the tweet object, obviously our table name or seed prefix has just changed to the word tweet. But here's what our seeds look like to create a tweet. You can see we have 3 now. So for starters, it's the seed prefix, the word tweet, makes sense. And then your profile. So let's think about like if I hash the word tweet with your profile address, that's pretty easy derivation. It's like I just need to know the word tweet on my front end. And then I've already showed you guys how we can derive your profile public key from your wallet address. So we have that. We can use that to get to here. But then you're not going to have just one tweet. You're going to have many tweets. So you need to add in the concept of like IDs. And this that I'm going to show you is just one way to do it. There's a couple ways you can do it. It's honestly up to your like creative expression. And if you honestly come up with a really good way to do it, you should share it, because it's kind of like, it's something that people are still working on and trying to figure out, is like how best to map data using PDAs. But for me, what I did is inside my profile object, you can see that I'm keeping a count of how many tweets that this profile has written. And so when I go to create a tweet, I load the profile up. And then when I write this new tweet, I'm just looking at that count and I'm marking this tweet with an ID equal to the count of tweets plus 1, right? So we have 0 tweets. We're writing a new one. This is going to be tweet number 1. And then once I create that tweet and it's confirmed to be created, we're going to change that value on the profile to be 2, and so on and so forth. And now when you're looking up the tweet using the address, you can just look up tweet count plus 1, and that'll be your seed. Now, that is specifically for the instance of creating this tweet, right? So when we're passing in, when we're looking at the profile, if we're creating a tweet, this is going to be 0, and we're going to turn it into 1, and that's going to create the address of this hash. Now, when we go to create another tweet again, this will be incremented. The tricky part here is you're going to need to know this number to get any single tweet, right? So if you want to look up tweet number 3, right, you need to pass in a 3 here to get the hash. Like if you're going to do this on your client side. So that's where there's a little bit of like an issue, is like you need to know that number if you want to get a specific tweet. But I mean, it kind of makes sense, because if you think about like a database, if we're looking up, if you wanted to like query a certain tweet by somebody's Twitter account, you would have to know the tweet ID, or maybe you'd have to know some other parameters like what's the like time it was tweeted or whatever. So like maybe you can use, instead of like this tweet count, you can use something like that. But ultimately you'll need to know the number of the tweet to get it from this derivation. But once you do, every time you hash together the word tweet, the profile public key, and the number, the ID of that tweet, you'll get its address and you can look it up on chain. So that's a repeatable process. And the neat thing is when we do something with a counter, what you can do and what our front end is doing is you can basically look at the profile and you can say, okay, this person has 3 tweets that they've created. And so you can start with number 1 and you can derive the tweet using these seeds for tweet number 1. And then you can move to 2 and you can derive the address for tweet number 2, move to 3, derive the address for tweet number 3. And then since 3 is the number of tweets that this profile has created, you know to stop there. That's just one way to do it. Honestly, you don't ever really have to write that yourself though, unless you specifically needed to like look at certain tweets for any reason in your app. Like your front end might have to leverage some of that, depending on it, like how you built this out. Like I'm just showing all of them at once, so like it doesn't really matter for me. But if I wanted to show, like if I wanted to be able to like click a tweet and open it up, you'd have to know the ID. But the nice thing about like front end, like how you can set some of this up is if you have this tweet sitting here and it's already been loaded into your front end, you can look at the tweet object and you can see its ID. And then you can just grab it and you can use it to actually look it up. Or if you already have the data, you really don't even need to look it up again. You can just expand this data into a different component, whatever you want to do. But I'll show you guys in Anchor. Another cool feature of Anchor is you don't need to actually write any of that stuff yourself. With native, you kind of do. But with Anchor, let's say we want to do get profile. You can see that here we're doing Twitter, like program.account Solana Twitter profile. That's the type of account. Fetch. And we're feeding it this profile public key, which we're using this seed util thing to get. And I'll show you what this looks like now because I promised you I would. But that's just what I talked about. It's just using, like if you look at profile PDA right here, here's the seed prefix, the word profile, and the person's wallet public key. We know this already, right? Like that's always going to give us the profile. So we can reference it here when we want to load someone's profile on the front end. We can just fetch it with its address. But when you want to get all tweets, you can see right here, get all tweets. Again, we're using program dot, let's see, up here, right? Yeah. So program.account.solana tweet, but with Anchor, you can do .all. And this is actually so handy. I'll warn you, it is a little slow sometimes if you have like a shitload of accounts, but you basically can do .all and it will just, it doesn't care about any seed derivations or anything. It's going to just make sure that your account matches this data structure and it's going to pull them all. And then obviously you can see what I'm doing is I'm just looping over them and filtering them. So that's all you need to do for that. But then to get a specific one, you can see that we're going back to the fetching. And so in this case, I'm doing like, here's my tweet public key. I'm passing it in to be fetched. And then let's see if I can find it on the, I don't think I ever used that one to just get one tweet. But still, you can see that that's how you do it to look up those accounts. So that's basically it, guys. Like that's a good overview of some really core concepts of building on Solana. So like we saw the create Solana Dapp CLI. We saw some of the cool stuff that comes along with using a prefab scaffold that like, which is what that CLI will give you. So all the different components. We saw the wallet multi-button. We saw the auto connect context and like the ability to support different wallets in that modal. We saw all that stuff. And we also saw how to put your IDL into your front end, how to use it to create an anchor provider, and how to like use that program object to actually run your instructions against your program. And then we also saw how to create PDAs and tokens on chain. And like this is just what it looks like to create a token real quick. Like you just initialize the account, and if you provide these values, these like attributes, Anchor is going to know that it's a token. It'll initialize it as a new mint. And then I've just added this additional operation to go hit the Metaplex program and create some metadata for that mint. So that's all that this is. Unfortunately, it's a humongous looking function, but this whole thing is just one function. So that's how you create the tokens. And we also saw like we're creating a couple different objects that have like relational mapping to each other. And we talked about how like these are program owned accounts. So like our program can read and write the data at any time. And we also talked about how they're related to each other. So their addresses and their seeds have like a certain schema to them. And, like you guys can always reference this code if you want to like look at my implementation of how I do this. You can see like this is the counter method, if you will, of like having dynamic seeds and derivations. But this is like, if you can grasp these core concepts, then you could build whatever you want on Solana, right? Like you can build applications that can leverage on-chain data in ways that are very similar to Web2, like SQL Server indexed data. So it's a little bit tricky, I understand. And there's kind of a lot to unpack here, but I tried to just give you guys all of the most important concepts. And you can reference the code at any time. And as long as this thing's online, feel free to play around with it. But it's all DevNet, so don't try to like drain me. And then, that's really it, guys. The biggest thing to understand is these PDAs and how to do the seeds. And once you figure that out, you're off to the races. So cool. Feel free to mess with this app for the next few minutes, but I'm just going to leave it open for questions for the next 5. And feel free to just throw things in chat or whatever you want to do. But appreciate you guys coming out, and hopefully you guys learned something.
I can help pull some of those questions up for you. It looks like we got one asking for the GitHub link. Do you happen to have a repo for those dApps?
Yeah, I threw 3 links in the chat.
Oh, I see the GitHub link. Let me just post that for you. Cool. Well, we'll leave it for another second. Thank you so much for walking us through all of that.
Yeah, totally.
That was great. We'll give it another second for chat to catch up with us. And if not, we will let everyone go, take a quick break. We have our next stream starting in just 4 minutes. So y'all can go have a quick little break and then come on back. Alrighty. Cool. Well, it doesn't look like any other questions are coming in. Thank you so much, Joe. Any parting words for the attendees here?
Honestly, just thanks again. And if you ever want to reach out to me for anything, this is my Telegram handle. You can hit me up with like development questions. You can ask whatever you want, basically. I don't really care. And just try to wrap your head around like how Solana manages data and store state, and you should be able to build whatever you can kind of create, like whatever you can drum up. But thanks.
All right, cool. We'll catch you later. Bye.
Yep. All right. Bye-bye.